This video will include an overview of the main project objectives, as well as an overview of the selected design and 4 alternate designs. Next, we'll present our evaluation methods as well as concluding thoughts. Our main project objective is to score the maximum amount of points, with the secondary objectives of fitting in the bounding box, completing each subtask, and running within the 40-second time constraint supporting our main objective.
The design we went with is called the Sabertooth. The pneumatic pistons extend pushing off of a wall. As this compartment moves towards the matrix, it pushes out the arms located on the front corners of the stationary base. These arms will fall outwards towards the programming modules and extend slightly past the modules. A motor will later pull a string bringing the arms towards the base and drag the modules into the home zone. As the arms are collecting the programming modules, the compartment on the horizontal slide continues to move forward until the front end hovers over the sentinel in the center of the home zone. A second set of drawer slides will continue to slide all the way into the EMP zone. On this angled drawer slide is the compartment that holds the pill and Morpheus subsystems. Once inside the EMP zone, a long arm switch will be positioned to click as the beacons pass across the arm. The click will act as an input that will turn a motor connected to a partial disc that initially blocks the pills from falling out. 2 balls will fall out after the initial sensing of the red zone. To retrieve Morpheus, an arm with an open box attached to the end is connected to this last compartment. A set mousetrap is engaged in the last 15 seconds of the round, and the arm swings overhead Morpheus. The box surrounds Morpheus, protecting him from other arms. A motor on the stationary base promptly pulls a string to retract the horizontal drawer slides and pulls the Morpheus arm towards the home zone, dragging Morpheus with it. The final subsystem removes the Sentinel from the home zone by dragging it back to Zion. Connected to the second compartment is a tooth-like mechanism connected to a hinge. When the compartment slides out and stops over the Sentinel, the tooth will fall over due to the momentum and hook around the Sentinel. When the string pulls the compartment back to Zion, the Sentinel is brought back with it until it is out of the home zone.
Our first alternate design is the pusher. The pusher contains a pneumatically actuated wedge that enters the red zone in order to try and dislodge the pills of opposing teams. The wedge doubles as a ramp for our own pills to be placed. This piston also releases the arm that retrieves Morpheus and drags him into the home zone. The spring-loaded flap at the bottom drags the Sentinel to the EMP zone. The expandable compartment is released with a piston, which also collapses the arms used to collect the programming modules. The ends of these arms are wedge-shaped to move the programming modules towards the home zone without using another actuator to retract the arms.
Our second alternate design is the flapper. This design has 2 arms that extend out in front of the programming modules and sweep radially to trap them in. It also has a platform which uses drawer slides to extend out to the matrix. On this platform are 2 tubes which will hold the pills and will be released by a sliding door. On top of the platform is a lever arm with a cage attached that will trap Morpheus and bring him back. Underneath the platform, another arm will extend to catch the Sentinel as the system egresses from the EMP blast zone.
The scissor arm design is centered around a scissor lift style arm located on a stationary platform that is used to retrieve Morpheus from the matrix. Attached to the bottom of the scissor arm is the pill dispenser subassembly, which uses a gear and a partition conveyor belt to dispense pills into the correct zone. A sweeping arm is used to remove the Sentinel and knock it into an opponent's zone. Finally, 2 long arms are used to retrieve the programming modules and bring them into the correct zone.
Our last design features a simple solenoid-controlled pill release, a flap to drag the Sentinel inwards towards Zion, expanding arms to pull the programming modules inward, and a spring-loaded arm to catch Morpheus and drag him in during egress. The slides on the bottom are mounted sideways for vertical stability at the expense of ease of construction. An evaluation matrix was used to evaluate each design against each other. Here, the Sabertooth design comes ahead with 281 points. The team determined that retrieving the programming modules and removing the Sentinel would be the most attainable source of points, and hence weighed success in those categories highly, both of which the Sabertooth design performed well in. However, the Sabertooth design was able to further differentiate itself by its strong ability to egress successfully and place pills in 2 red zones, giving it a high scoring potential. In conclusion, the selected design is well-rounded as it has 3 robust subsystems. However, the Morpheus retrieval subsystem must be focused on to increase scoring potential. Thankfully, this design has high durability and should be able to withstand rigorous testing. Thank you for your attention throughout this presentation. Feel free to ask any questions.